In the previous video, we explained what logical consequence is, what does it mean that an argument is valid. And we said that an argument is valid just in case there is no interpretation of the non-logical vocabulary, where the premises are true and the conclusion false, right? Now, I want you to notice that this definition of logical consequence, in order to specify a particular notion of logical consequence, we have to specify a language in which we give a neat separation of logical and non-logical vocabulary, and what an interpretation for that language is, right? And this is what we are going to do right now for the classical propositional language, right? So the classical propositional language, right, contains a vocabulary divided in non-logical and logical vocabulary. The non-logical vocabulary is composed of propositional variables, right? So the propositional variables are like the bricks, the most basic sentences of our language. And the logical vocabulary is composed out of conjunction, disjunction, negation, conditional, and a couple of parentheses, right? So these logical connectives are like the glue to put the bricks together, right? And so that we can specify a set of rules that will tell us which sequence of expressions of the vocabulary are part of the language, right? This is pretty easy. Probably all of you know that, so I'm not going to comment on that. You will see them on the notes. So that's language, right? Now let's go for the semantics. Now, an interpretation, intuitively speaking, an interpretation is substituting the variables by sentences, right? Because these variables are just telling you, here you should plug in a sentence, right? Now that's the intuitive idea of an interpretation. But it turns out that in logic, we don't care very much about what sentences say, right? So we make a big jump of abstraction, right? This is a big idealization. All what matters for us is whether a sentence is true or false, right? So we will take that an interpretation is a function assigning truth values to the propositional variables, right? An interpretation is an assignment of truth values, true, 1, false, 0, to each propositional variable. This is a huge idealization, right? But this is the way logic works. Now, after we have considered what is an interpretation for the non-logical part of the vocabulary, we would like to know how an interpretation extends to all the formulas, right? So you give an interpretation for the most basic formulas, and then we would like to know how this interpretation for the basic formulas extends to all the formulas of the language, right? And this can be easily done by some clauses. This is called a recursive definition. We won't fuse too much about what a recursive definition is, but intuitively speaking, we have set the conditions of a complex formula. So when a complex formula is true in terms of the components, right? So that you start to analyze a complex formula and you can go down to the propositional variables, right? For the case of conjunction, we will say that a formula of the form A conjunction B takes value 1 is true, just in case both A and B take value 1 in that interpretation, right? For the case of negation, a formula of the form negation A is true in an interpretation just in case the unnegated formula is false in that interpretation, right? So this should match our intuitions about conjunction and negation, right? So let's see how this works with a particular example, right? So given an interpretation for the propositional variables, this interpretation will induce a unique truth value for any formula of the language, right? So consider the following example. We've got here this formula, right? And we've got an interpretation for the propositional variables in that formula. This interpretation gives us the value 1 for P, the value 0 for Q, the value 1 for S, and the value 0 for R, right? So we can analyze this formula in a tree, and you can see that for this particular case, right, since P takes value 1 in this interpretation, and Q takes value 0, right, by the clauses of conjunction, right, conjunction takes value 1 just in case both take value 1. We've got here that P takes value 1, but Q takes value 0, right? So this is going to take value 0. P conjunction Q is going to take value 0. Now we've got this formula here, right? So P conjunction Q takes value 0, but the disjunction, in order to be true, requires just one of the members to be true, and S takes value 1, right? So that's enough to make true this disjunction. So this is going to take value 1 in that interpretation. Now R takes value 0 in the interpretation, and this, the antecedent of this conditional, takes value 1, right? And this is the unique case in which the conditional takes value 0, right? So this is going to take value 0, and that was what it is sometimes called the main logical sign of a sentence, which tells us the truth value of that sentence. And in this interpretation, this sentence takes value 0, right? We've got all the ingredients now to give our definition of logical consequence, which we will make soon in the next video.